Hello, everyone. It's a pleasure to have you all here. Our ladies room and our users group. We are presenting using Python within Stata, presented by Dr. Chuck Huber. I had the pleasure of meeting Professor at the North American Conference of Neurology. So I'm very happy that he accepted to talk with us today. So let's go. Disclaimer: this talk is recorded and will be posted on our YouTube channel. If you don't want to be recorded, feel free to turn off your cameras. Please remember that all our attendees are expected to adhere to our code of conduct. Raise your hand and use the chat to introduce yourself and asking questions. We ensure a safe, inclusive, and harassment-free space for learning. Hello, everyone. I'm very happy to welcome here to our September event. I'm Rafaela, our Ladies Room chapter organizer, and get ready for engaging and informative experience. What to expect from this call? Combine Stata and Python, explore practical examples, leverage Python libraries, enhance workflows, and some tips and tricks. As in our community, we value open knowledge, critical thinking, and exposure to diverse tools. Many our users work in multidisciplinary teams or contexts where Python and Stata are also a part of the workflow. By hosting this talk, we expect to foster understanding of different analytical paradigms, highlighting integration opportunities, and strengthen our ability to make informed methodological choices. This is not about promoting software, but about enhancing our community perspective of our users to navigate real data challenges with confidence. So just remember, what is Our Ladies? It's a global community with the mission of promoting our language at all our users, building a collaborative global network. It's a friendly community founded in 2012 by Gabriela Queiroz. It's a space for free learning resources, networking and mentoring, focused on diversity. So this is our organizers, Federica Gazzoloni, May, Lucy Michaels, and Leticia Lopez. Okay, so Our Ladies roam in numbers. Our community has been growing up a lot since 2022. Here in the right, we have our top 10 events. We explore data visualization, R production, interactive R and Python, and Shiny, quarto dashboards, GitHub, and other types of presentations. So join us and follow us. If you are interested in speaking at one of our events or would like to propose a speaker or workshop, please scan the QR code and fill up the form. Here in the right, we have Speak to Our Ladies Room, and in the left, Suggest a Speaker. So, without further ado, we're honored to welcome Dr. Chuck Huber, Associate Director of Statistical Outreach, StataCorp. Dr. Huber is widely recognized for his experience in applied statistics, epidemiology, and statistical education. He has authored numerous tutorials, led international workshops, and he is passionate about making complex methods accessible to all. Today, he will guide us through exciting intersection of Python and Stata, sharing insights that will be a broaden to our perspective as an our community. Please join me in giving a warm welcome to Dr. Chuck Huber.
Well, thank you, Rafaela, for that very nice introduction, and thank you for having me today. This is really exciting. It probably seems a little strange that a Stata person would come talk to a group of R users, but I think it's actually kind of fun, and maybe I'll learn something today as well. Let me see if I can share my slides here really quickly, and we'll get started. Okay, can everyone see the slides? Okay, perfect. So today I'm going to talk about an introduction to Stata and Python integration, and I'm going to go only in one direction, but just so you're aware, you can use Stata from within the Python world as well. I don't understand it. I've never used it, but there's a way that you can use Stata from within Jupyter Notebooks, for example. So you can use Stata from other software. I just don't know how to do that. It's not my thing. I'm going to show you how to use Python from within Stata. You can download all the materials at this tiny URL. I pasted this into the chat window earlier, so hopefully it's still there and you can download everything, the slides, the data sets, all the programs I'm going to show you are in a zip file and you can grab them there. So, I'm going to try to make the argument today that Stata and Python work very well together. I'm not going to try and argue that one is better than the other. Well, my point is that they both have certain strengths, and I think it can help a lot to learn how to use both and leverage the strengths of both. Because some things are just much easier to do in Stata than they are in Python, and there are other things you can do in Python that are just harder to do or you can't do within Stata. So I'm going to try and show you some things of how to use them together in order to sort of maximize your or minimize your research frustration. So Stata is particularly good at things like data management, basic graphics, statistical modeling, things like that, reporting, markdown. We've recently added a lot of machine learning features. So you can do things like random forests and gradient boosting machines like that from within Stata. You don't need Python to do those things anymore. There's also a huge library of user-written commands out on the internet. So a lot of people think that R and Python are the only places where there are a lot of user-written commands and you can download those. But Stata's been doing this for decades. So there are a lot of features that are not in official Stata that are available in Stata through user-written commands, just like there are in Python and R and other Julia, things like that. By the way, if you have any questions, just unmute your microphones and ask questions. I can't see the chat window or anything in presentation mode, so feel free to just jump in and interrupt me at any time, and I'll do my best to answer your questions. Okay, so Python. Python is very good at 3D graphics. Graphics in general, it has an amazing collection of graphics features. It also is very good at dealing with API access to data, and I'll talk more about what that is here shortly. But Python is particularly good at accessing data across the web using APIs. A lot of times when we get data from the internet through APIs, it comes down as JSON data. Some people call it JSON or JSON or XML, but these nested sorts of data structures, Python is very good at handling those, and I'm going to show you some examples on how to do that shortly. Obviously, Python has an extensive collection of machine learning features and thousands of other packages for doing all kinds of things with artificial intelligence and other things. So the point is that they each have their strengths, and what I want to try and show you today is how to use both together to sort of leverage the strengths of both. So as an example, I'm just going to show you some examples first, and then I'll go through and show you how to do these examples. So this is an example where I fit a logistic regression model for high blood pressure using age and weight, as well as the interaction of age and weight. So age is treated as continuous, weight is treated as continuous. And then I'm going to do some marginal predictions from this logistic regression model. So I'm going to calculate or estimate the predicted probability of hypertension given certain values of age and combinations of age and weight. Now, in Stata, I would usually show this as a contour plot, but some people like these three-dimensional plots. And so here, the first three commands are Stata commands. The first one opens the data set, web views. The second one fits the logistic regression model. And then the third line there, third and fourth lines, estimate the marginal predictions that are used to create the graph. Okay. So 3 lines of code and boom, you've done it. You've opened the data set, you fit the model, you've done the marginal predictions. That part's really easy to do in Stata and much harder to do in Python. But you can't create a 3-dimensional plot like this in Stata, and I'm going to show you how to do this here shortly using Python. As I mentioned earlier, Python is particularly good at using APIs to go out and request data from across the web and then processing the resulting JSON data or JSON data. And this is an example where I've used 2 different APIs to go out to the web and grab data from Yahoo Finance and from a thing called the OpenFDA. In the United States, the Food and Drug Administration that monitors and licenses drugs and things like that is called the FDA, or Food and Drug Administration. And they have a website where you can go and download information about for instance, adverse events and things. And I'll show you how to create this graph later. So here I've used I've used Python to go out to the web, request the data, pull the data back in JSON format and process the data. And then I'm using Stata for the graph because it's, in my opinion, much easier to create a basic line chart like this in Stata. So again, we'll go through and see how to do these examples shortly. This is a command. I wrote a blog post 3 years ago, 2 or 3 years ago, maybe two. Anyway, called ChatGPT. Right when ChatGPT came out, it was all the rage and everyone was talking about it. And one day I was eating lunch and I thought, it can't be hard to write a little Stata command that would use the OpenAI's API to talk to ChatGPT across the web from within Stata. So while I was eating a sandwich one day for lunch, I wrote this little command called ChatGPT. So you just type the command in Stata, put your prompt in double quotes, and it sends it through it sends it via Python through the OpenAI's API and sends it into ChatGPT, and then it retrieves the response from ChatGPT through the API, and then it prints it on the screen and saves it to a file. And again, I'll show you how that works here shortly. These are just examples of things you might want to do. As I mentioned earlier, Python has an very extensive collection of machine learning and artificial intelligence features that are not in Stata, but a lot of Stata users are not very comfortable writing their own Python code. So some Stata users like writing Stata commands, and you can create Stata commands that use Python as the computational engine in the background. So there was a doctoral student at Harvard. He was a economics or econometrics PhD student at Harvard. I guess he had too much free time on his hands, and he wrote a suite of commands in Stata. These are all Stata commands: PyTree, PyForest, PyMLP, and so forth. He wrote this collection of commands and put it out on GitHub, and they are Stata commands that are running Python in the background. So the user never sees or has to type any Python code at all. They don't even know that they're using Python. They think they're using Stata commands, but in fact, it's actually running Python in the background. So this is a really fun thing to do. I think it's tremendous fun to create Stata commands that use Python in the background as the computational engine. So this is what I'm going to do. I'm going to walk you through these examples and how to do them. Parts of it are going to get fairly technical because it's not much fun to see that you could do this and then not learn how to do it. So particularly the middle sections on passing data, passing information from Stata to Python, and the Stata function interface, those are fairly technical because I'm going to show you the details of how to actually do that. And then I'll walk back through the examples again once I show you how these things work and explain how to actually do those examples. Okay. And again, if you have questions along the way, please jump in and just unmute your microphones. So the first thing we would need to do, I'm assuming that you have limited experience with Python, and I apologize if you already know all of this, but for those of you who are not familiar with Python, you can download it from python.org, and they have a web page for downloads. You can download Python for Windows or Linux or Mac or whatever you're using. Stata also runs on Windows, Linux, or Mac. So that's another thing that makes these run nicely together is that it doesn't really matter which platform or operating system you're using. Stata and Python work on all of the three major ones. Okay. Some people prefer to use Anaconda. So rather than just installing Python by itself, they use Python from within the Anaconda IDE or integrated, I forget what the D stands for, but integrated development environment. That's it. So if you download Python through Anaconda or with Anaconda, you're going to get a lot of packages with it. And so you won't have to download the packages by themselves. And a lot of people prefer this Anaconda environment. So once I've downloaded and installed Python, the next thing I need to do is tell Stata that I have installed Python and tell it where I've installed it. So the first thing you might do is type Python search. So from within Stata, just go to the command line, type Python search, and it will show you any Python installations on your machine. So I have two. This is a few years old now, but at the time I had two installations. One was plain old Python 3.7, and I also had an installation of Anaconda, so I could try this a couple of different ways. So those are the installations of Python I have on my machine. And now I need to tell Stata which of those do I want to use. So anytime I use Python from within Stata, do I want to use plain old Python or do I want to use the Anaconda version? So what I can then do is type set Python underscore exec. It's setting the executable, or it's telling Stata where the Python executable is located. So, and it will, you can find that again by typing Python search and it will show you right where it is. So copy whichever one you want to use into set Python execute and it will give you some red ink and it looks like an error message, but it's really not. It's just telling you that, okay, you've told us where Python is. Now you need to restart Stata so that Stata knows where to find it. So that's all it's telling you. It's not really an error message. The other thing that you'll want to do is set the user path so that any packages that you download can be found easily by Stata. So that to do that, you would type set Python underscore user path, and that's usually the same path as your executable. So when I told it where the executable is located on my machine, that was in C colon program data slash anaconda 3. And the executable's in that folder, so that's why I have the executable file there. And the user path, I just need that path. Okay. And again, it's going to give you some red ink that looks like an error, but it's just telling you you need to restart Stata so that Stata knows where to find those packages and modules and things. Okay. So once you've done that, you can just type Python query just to double check your work to make sure that you've told Stata or Stata and Python are now communicating. Okay. And it tells you below, is it initialized? Yes. Which version of Python are you using? At the time, I was using Python 3.7.4 with a 64-bit architecture, and it's telling me where the Python library path is. Okay, so that's what Python query will do for us. Now, you're probably more familiar with this than most, especially than most Stata users, but Python has a ton. I mean, a ton doesn't even come close, thousands and thousands of packages that are freely available out on the internet. You can go out and download these manually, and I'm going to show you how to do that here in a moment, but many of these are automatically installed if you use Anaconda. So when you install Anaconda, it will install a lot of these frequently used packages along with Anaconda. Now, one of the issues that comes up with this, and if you're using R, I'm sure you're very familiar with this issue, is package dependencies. So if you have a package for doing matrix multiplication, excuse me, there's no reason for you to write a new package or a new command or new code in your package that does matrix multiplication. You would just call another package. And that package may call another package, and that package may call two other packages. So this is a image that I grabbed off the internet that just shows kind of a small web of interdependencies among packages. And this is a good thing, and it can be a problem as well, or an issue. It makes coding easier because you can call these other packages that already exist. So it makes your package development a little bit easier. You don't have to write so much new code from scratch. But if one of these package changes, which they do frequently, those changes can propagate through the entire web of dependencies. And so what can happen is sometimes you run a package that you've been using for a while and suddenly it doesn't work anymore. Or you run it and it gives you different results than it did the last time. It's just I mean, if you're using R, you're well familiar with this idea or concept, so I probably should just move on. But it's important to, if you've not done this before, to you may need to be updating packages frequently. So if you're using plain Python or you're using Anaconda and you need a package that isn't installed, there's a little program called pip that you can use to install Python packages. And what you do is you go to your operating system window, just to a generic prompt, and you type pip install, and then you tell it the name of the package. So NumPy, some people call it NumPy or NumPy or whatever, but it's a very basic math package. It does a lot of basic things, addition, multiplication, squaring things, lots of functions like logarithms and things like that. So that's one that you will almost certainly have to install to do anything to do with statistics or math, NumPy. So pip install NumPy. Another package that's frequently used in Python world for computations or dealing with data is called pandas. When I first I thought it was pandas, like the animal, and at the Beijing Zoo, but it's actually pronounced pandas. So again, we would type pip install pandas, and that would install that package. We're going to be using matplotlib or matplotlib. People pronounce it differently. This is commonly used for some, I was going to say basic, but it does some fairly extensive machine learning and basic artificial intelligence computations. So matplotlib, oh, I'm sorry, I'm confusing that. No, this is the plotting, graphing library. Matplotlib does extensive graphics, including the 3D graphs. So that's matplotlib. Scikit-learn is the one that is the contains a lot of machine learning and artificial intelligence features. So pip install scikit-learn. Now, one Python space which, and then tell it the package name. So I might could type Python which numpy, and that will show me where that module is stored on my local computer. Same thing with pandas or matplotlib or whatever. Okay. So Python which will locate packages for you. If this is a little confusing, I've recorded some YouTube videos. One of the things that I do at StataCorp, or used to do more often anyway, is record YouTube tutorials. So I've recorded tutorials that literally walk you through how do you download and install Python, how do you install Python packages with pip, and how do you install Python using Anaconda. But how do you install Anaconda, which includes Python in it? So these are links. So just open the slides, click on the hot links, and it'll take you to those YouTube videos, or you can just go to our YouTube channel. Okay, so any questions about this so far? This might be a good place to pause. Okay, so far so good.
We
Oh,
have
question?
a question in the chat. What are the advantages of using integration of them?
Well, as I mentioned at the beginning, there are certain things that Stata does very easily and quickly. This is probably my favorite example because in 3 lines of code, in Stata, I can open a data set, fit a logistic regression model, and generate marginal predictions from that model. I can generate the predicted probability of the outcome for a bunch of combinations of age and weight. And I can do that in 3 lines of code in Stata. I've done this in Python just for fun to see how hard it is. This would take a lot more code, at least 10 lines of code, probably more, to fit that to open the data and fit the model and generate the marginal predictions. That's not as easy to do in Python, not at all easy to do in Python, but it's trivial in Stata because Stata is built as a statistical software package. Python is more designed as a programming language. So that's why I would use both. I would use Stata to fit the model and generate the marginal predictions, and then I would pull that data into Python to do the surface plots from it. What I'm trying to do is leverage the strengths of each package, each software package. Stata's good at some things, Python's good at some things, and I'd rather use the best and easiest tool for the job. Does that answer the question at all? Or was there more to it? Okay, any other questions before we move
I
on?
have another question. Yeah.
Sure.
Yeah, for example, how we can handle this version control when we are using both of these tools together.
Okay, that's a really good question. So Stata
Yeah,
has a concept of
version
version
control
control.
and reproducibility. Yeah.
That's a very good question. So Stata has a concept of version control. So if I'm using Stata 19, I can actually type at the top of my batch file, or we call them do files. I could type Stata 15, and what it will do is it will run my do file as though I'm running it in Stata 15. So why might I want to do that? Well, in Stata 15, we updated the random number generator. We used to use the old KISS random number, the Keep It Simple Stupid, which was the industry standard at the time for random number generation. And Stata 15, we switched over to the Mersenne Twister, which is a more state-of-the-art random number generator. So if I ran it in Stata 15 or prior, or 14 or prior, if I used anything that generates random numbers, bootstrapping, MCMC, just drawing random numbers. Anything that deals with random numbers would be different if I ran it in Stata 15 versus Stata 14. So I can type Stata 15 or 14 at the top of my batch file and run it as though I'm using the old Stata 14. So it's really easy to use things and do them as though in a way that's backward compatible. If you wrote a batch file and created a report in Stata 14 and you're using Stata 19, just type Stata 14 at the top of the batch file and everything runs just like it did in 14. The problem with package dependencies in Python is that there is no concept of version control. And so what you run today, if you go and run it later, if you update one package, it may require an update of multiple other packages. And that can cause a lot of frustration because something you run today may not work tomorrow. You come to the office and you fire up your computer and you run your batch file and it doesn't run today at all. And then you have to go update some of your Python packages and then it will run. But then once it runs, it may not give you the exact same answers that it did before. Someone may have changed something or added some features to something that makes it round in a slightly different way. And so you may get different answers in a second or third decimal place. So package dependencies is an inherent problem anytime you're dealing with open source software, not just Python, but R or Julia or any of these. There are advantages and disadvantages to them all. So yeah, it's just an issue with open source. But again, Stata has solved that by using version control. Now, I don't want to go too far down this road, but there is a company called H2O in Palo Alto. I've driven past their building out in Palo Alto, California, in the United States. And what they do is I may be wrong about this, but as I understand it, they take Python and bundle up a collection of packages into a version, if that makes sense. So they take a Python executable and take a bunch of packages that are typically used with machine learning. They'll bundle them all up into one release and call that H2O version whatever. And that's actually what Stata is using for its machine learning features in the background. So you don't have to deal with those package dependency problems. And that's part of what H2O has tried to solve is that package dependency issue for Python. So if I'm wrong about that, somebody please jump in and correct me, but that's my understanding of what H2O has done and the value that they bring to the market. Any other questions or corrections about my interpretation of H2O? Okay. So let's talk about using Python within Stata. So how do you actually do this, the nuts and bolts? So there are 4 different ways. One is using Python interactively. Another second is using the Python prefix. Third is running Python code blocks. And then the last one is running Python scripts. So let's walk through each one of these. The easiest way to use Python within Stata is to just type Python in the command window, type some commands, and then type end when you want to go back to Stata. So this is the Stata window. I wrote this talk in Stata 16. We're on version 19 now, but it works the same way. So the command window in Stata is here at the very bottom. And so I can just type Python. So you can see that in the results window, I typed Python. Then I typed print hello Stata, I am Python. So that's a Python command. It will run, because I'm in Python mode, it will run using Python, display the results, hello Stata, I am Python. And then I typed, just for fun, 2 times 3, and that Python reports that the result is 6. And then I type end, and now I'm back in Stata mode. So I'm within Stata, but I'm using Python, okay? So that's probably the easiest way, but not the most likely way you'd use it. And again, if you want to just see it as a Stata command and results, here's the command at the top and the result at the bottom. Okay. Now, a more likely way you would use this is Python code blocks from within a batch file, which again, in Stata, we call them do files. It's just a text file with a .do extension. But it's a collection of commands for Stata. And so I can write one of these do files, and I can write a bunch of Stata commands. I can write a bunch more Stata commands. And then I think, oh, well, I want to do something in Python. So all I need to do is type Python : in my batch file, type a bunch of Python commands, and when I'm finished, I type end, and then I go back to typing more Stata commands. So a stata do file can contain both stata commands as well as Python commands. Okay. And you just switch between the two by typing Python : and then end when you're finished. So as an example, if this was a do file at the top, I can type Python : and then in double quotes put hello stata, I am Python, and then type end, and away we go. And again, what that's going to do at the bottom is run the command in Python. Okay, so it's that simple. Now, you can also run Python scripts, and Amazon does this. So Amazon is a big Stata customer, and they have they use Python a lot for fetching data off of servers. But Amazon employs a lot of econometricians who use a lot of Stata. They prefer Stata for doing their data analysis. And so what they like to do is use these Python scripts that are already written for fetching data from the servers around Amazon and then pulling the data together and doing the analysis in Stata. So they don't want to have to rewrite all this. They just want to run their existing Python scripts, which have a .py extension. And so at the top, imagine this as a Python script in a file called hello.py. So there's a file on the machine called hello.py. In that file, it just says print hello Stata, I am Python. That's all that's in the file. In Stata, I would type Python script hello.py, and that will run that Python script, okay, from within Stata. So the result at the bottom, after I type Python script hello.py, it's going to run whatever commands are in that Python script, which is just hello Stata, I am Python. Okay. So if you have a bunch of existing or legacy Python code, you don't have to pull it into Stata. You can just run those scripts from within Stata. Now, the obvious question comes up because sometimes I type Python and then sometimes I type Python with a colon. What's the difference and why would I use them differently? So the difference is what happens when a statement fails to compile, if you have a syntax error of some sort. So if I type Python by itself with no colon, what it will do is it'll allow you to remain in the Python environment and the subsequent Python statements will continue to execute. Okay. So it just, okay, yeah, there's a syntax error, but it stays in Python and just keeps going. If I type Python : what that will do, and it runs into an error, what that will do is then exit the Python environment and return control to Stata. Okay. So if I initiated Python with the colon at the end and it hits an error, it's going to automatically return control to Stata. That's generally a safer way to use this because you probably don't want to get stuck in a bad error loop of some sort within Python and get Stata stuck in Python. So that's why I have a tendency to use Python : because if anything goes wrong in Python, it just returns control back to Stata. But for both of these, it will print a stack trace on the screen with the error codes, and that happens either way. So you can see what the error was. It's just a matter of what does control go back to Stata or does it stay in Python? Okay. So next up is passing information from Stata to Python. And you can go both ways. You can go send information from Stata to Python and back from Python to Stata. I'm going to show you the sort of basic way to do it first, and then the much more sophisticated way second. So first up, we need to talk about what are called local macros in Stata. So in Stata, we have data sets, but if you just want to store a number or a string or a list or something, we store those in macros. Macros can be global or local. So I don't know if you're familiar with the concept of global or local variables or macros or things like this, but local means it's local to the calling program. The reason you want certain things like that to be local is because if you have one program calls another program and you happen to have used X, the variable or macro X in both programs, and one program calls the other program, the programs will become confused if you use the same macro names in both commands. But if you specify them as local macros, so for in this example on the slide, the local macro X is local only to the calling program. So even if it calls another program that happens to use a macro X, Stata won't get confused. It's only going to reference the X within the calling program itself. So that's why we call it local X equals 2. There is a variant called global, and global makes it global across all calling programs. There are concepts like this. I don't know if there's a concept like that in R. It's a similar concept in Python and C and other languages like that. But anyway, so I can store the number 2 at the top of the slide here. I'm going to store the number 2 to a local macro named x. Then I can open Python or move control to Python by typing Python colon. And then I can refer to that x and then type end. And we'll come back to what that x looks like in a moment. But when I run this, it's going to store the number 2 to the local macro x. Python will then display that number or value of that local macro x, and then it ends and returns control back to Stata. Now, the X looks funny because it has a left and right single quote, and those are not the same left and right single quote. So if you've ever used Python, you're probably used to always using what Stata calls the right single quote. That right single quote is over by the enter key on American keyboards. Now, on other like Canadian keyboards, it may be in a different spot, but that's the right single quote. On the left of the macro name, we're going to type the left single quote, and on American keyboards, that's over on the top left of the keyboard, just above the tab key. Okay. So that can be confusing to Python users who are using Stata for the first time or Stata users using Python for the first time. We refer to a local macro using a left single quote and a right single quote. Okay. And you can use that local macro definition within Python and it will display it. So that's a way that I could pass a local macro from Stata into Python. I could then assign that local macro from Stata to a Python variable, or a number in Python. So I could define the local macro in Stata, so assign 2 to the local macro x, then type Python colon to start the Python engine. Then within Python, I'm going to type x equals, and then type the left and right single quotes for x. What that will do is pass that value of 2 from the local Stata local macro x into the Python variable x, and then below that, the next line just says x, so it's going to display the value of x and then end. So if I were to run that little Stata command, that code block at the top of the slide, the results at the bottom will pass that local macro into Python's variable x and then display x. So again, it's another way of passing information from Stata into Python. I could pass multiple local macros into Python, do something with those, and then assign them, like I could, in this example, I'm going to assign the number 2 to a local macro x, the number 3 to a local macro y, both in Stata. Then in Python, once I invoke Python, I'm going to multiply those 2 local macros, x and y, but I'm going to place the result in the Python variable z. And then I can type z to display the result of the product of those 2 macros, and it displays 6. Okay. So again, it's just a way of moving information from Stata into Python. Now, another way we could do this, what if we are using a Python script that has a .py extension? So I have somebody's already written this Python script, and I simply need to pass arguments into the script. So a way to do that is through arguments or sys.argv. So sys.argv is a namespace within Python that receives arguments and passes them through. So here's how I'm going to use that. If this is my script, my Python script, at the top of that, I'm going to type import sys and then arguments equals sys.argv. So that's going to accept arguments into this Python script. And then I can print those arguments. So let's run it and then come back and see what it did. From within Stata, in Stata, I would type Python script, tell it the name of the script, product.py, and then I'm going to type comma args 2 and 3. And I'm also going to use this global option so that it's global. The arguments can be seen or placed into the sys.argv. So those 2 arguments are going to be global. So they will be passed into the Python script product.py. Once I run this, it's going to run the Python script, passing those arguments in, and then it will show the result, which is 6. So it's going to take the 2 arguments, multiply them, and then display the results on the screen. So again, this is the script itself, and this is the stata command that I would use to pass those arguments into the script. Okay. So now I could also store local macros. So rather than typing the numbers directly into args, what I could do is have local macros defined and pass the values of those local macros through args into a Python script. So here I have assigned the number 2 to the stata local macro x and the number 3 to the local macro y. That's done in stata. Then I'm going to type Python script product.py, and the arguments that I pass in this time are not the numbers, they're the local macros x and y. Okay. So any questions about that? I know we're getting a little technical here, and I may be putting some of you to sleep, but any questions up to this point? I promise once we get past the nuts and bolts, then I'm going to show you how to use these things to do something more fun. Okay, so that's how you would pass numbers. At some point, though, you're probably going to want to pass data, actual data from Stata into Python. And so the way I'm going to show you how to do this by passing data from Stata, Stata data set into a Python pandas data array. So I'm going to type sysuse auto and Stata. That's how I open a system data set, Stata data sets that are built into Stata. This is a very popular data set we use for lots of examples in our manuals called the auto data set. And I'm going to type keep, mpg, and weight. Those are two variables in this data set because I want to create a very small version of the auto data set. So I'm going to keep the variables mpg and weight. And then I'm also going to keep the observations 1 through 5. So keep in 1-5 says only keep the first 5 observations in this data set. So if I type list, this lists the entire data set. So the whole data set now has 2 variables and 5 observations. So it's really small. And I'm going to save this as a data set called small auto. So this is going to be a small version, a Stata data set that's a smaller version of the bigger auto data set. So now I have this small auto data set. I want to pass that into Python. So I'm going to do that by typing Python : and then import pandas as PD. Now, I'm not entirely sure why they do this, why we have these aliases. So import pandas is going to import the pandas package, but we're going to use the alias PD to refer to the package pandas. Okay, so import pandas as PD. So anywhere you see PD in the code after that, that really means we're referring to methods that are stored in the pandas package. Methods, by the way, is Python jargon. I don't know if this is the same in R, but Python has its own jargon. They refer to things as methods. What I would call a function, mathematically, they're more like functions. But the Python jargon for them is methods. So packages have methods. So the next thing I'm going to do is type small auto equals pd.read_stata and then tell it the file name. So what this is going to do is in the pandas package PD, there's a method or a function called read stata. So that is and it's going to take the results of that function or that method and it's going to place it in small auto, which is a pandas data array. So it's going to read that small auto data set into pandas. So now small auto, if I just type small auto, that will show me the data that was contained in that Stata data set. Okay. Now, this is another thing. I don't know how it is in R, but this is something that is very different in Python. Notice that the observations are numbered 0, 1, 2, 3, 4. So anytime you talk about an index in Python, the index starts at 0, not at 1. So same thing if you were to type a loop. You wouldn't type for I equals 1 to 5 or observation 1 to 5. Listing starts at 0. Indexing in Python begins at 0. It seems a little weird, but I read some computer science articles on why other languages do the same thing. And evidently in computer science world, there are advantages to beginning your index at 0 rather than 1. But it's a little confusing, or it was to me at first. But just be aware of that. Python refers to observation 0, observation 1, observation 2. Okay. So that's how we could pass a small data set from a Stata data set into Python. Now, I could also write data from Python. So let's say that I have this small auto data in Python. I can then use a method called toStata. So I'm going to I'm going to take small auto, and I'm going to use the toStata method to create a new file on disk called new small auto.dta. And the first argument is the file name, the new file name for the data. The second argument is going to be the version of the Stata data set. Now, this is also a little odd. I don't know why you would think version equals 118 would create a Stata 18 data set, but it doesn't. They don't correspond to Stata 15, 16, 17, 18, and so forth. You'd have to go to the documentation. I think this is for version 16. Version equals 118 creates a Stata 16 data set. I don't know why that is, but that you just have to read the documentation. So now I can go back to Stata and type use new small auto, and it shows me the data that is stored in that Stata data set. Okay. So that's how I can pass data from Stata into Python, and then from Python back out to a Stata data set. And notice the index stored in the data set begins at 0, but Stata's observation listed as observation 1. Okay, something to get used to. So any questions about that? Do we need to wrap up at the top of the hour, or do we have 30 more minutes?
You can continue, it's fine.
Are you sure? Okay, I don't want to run over time. Okay.
No, it's fine, it's fine.
Okay, great. Okay, so those are some informal ways of passing information from Stata to Python or back. But there's a much more formal way to do this, and this is how I would suggest doing this if you're going to write your own commands or do anything that you really, really want to rely on. So we wrote a thing called a package called the Stata Function Interface, or SFI module. And what that does is it is a very detailed method or class or whatever you want to call it for dealing with data, passing data back and forth from Stata to Python and Python back to Stata. It can pass anything back and forth, not just data and numbers, but dates, frames, local macros, matrices, whether data is missing or not. Platform information. Are you using Windows? Which version of Windows are you using? Error codes, all kinds of things, value labels. So this is a way more sophisticated way of passing data back and forth, or information, I should say. It's not just about data. Any kind of information that you would need to pass between Stata and Python back and forth. I'm going to show you a few of these because it would take hours and hours to show you all of them, but I'm going to show you some basic ones. To use the SFI interface within Python, you're going to have to import this package. And there are actually subpackages within this. So the most basic form of this is type import SFI. Okay, so that's the full package. But you may only need certain parts of the package. So I could type from SFI import macro, and that will import the features that allow you to import macros, local macros, global macros, passing those back and forth. Or I could type from SFI import macro comma data, and that allows me to pass macros back and forth or data back and forth. So just several ways that you could use this. Tell Python you're going to be using the SFI module. So let's walk through some basic examples. And what I'm going to do is I'm going to highlight the SFI module information in red so that it sort of jumps out at you and it's easy to see, because the rest of it it should be somewhat familiar. So local macros can also be strings. They don't have to be numbers. So at the top where it says Stata commands, these are the commands I'm going to type, and the results box at the bottom shows you the results when I run those Stata commands. So I'm going to assign the name Bill as a string to a local macro named name. And then I'm going to invoke Python, And then I'm going to type from SFI, import macro. That way I can use the macro SFI features. And then I'm going to create a Python variable called name, and that's going to equal the name from the local macro that was in Stata. So the function or the method would be macro dot get local. So get local means get a local macro from Stata name. Now notice that name in this case has the same single quote at the beginning and the end, because this is a Python method or a Python function. So I know this seems confusing, but use the Python right and left single quotes here, not the Stata left single quote. Okay, because we're doing this within Python now. So that will take that local macro, and then we can print the name. Again, we assigned name to a Python variable, and then we end. So if I run this at the bottom, I assign Bill to the local macro name, run this, it prints the name Bill, and then I end. Okay. So macro is the package, and get local is the method or the function within that macro package that I use to get a local macro from Stata. And again, I can't emphasize this enough because this is a syntax error you will make a lot in the beginning, and it's frustrating. Is if you're going to use the SFI interface, you need to start using Python single quotes rather than Stata's left and right single quotes. Okay. Now, what if I wanted to send something back in a local macro to Stata? Excuse me. So I could pass Stata in as a local macro named name, invoke Python from SFI import macro. And so now I'm going to assign the local macro name to a Python variable called name. And then I'm going to create from within Python, I'm going to type hello equals hello in single quotes plus name. And it's going to pull name from what I passed into Stata, from what I passed into Python, plus space, comma, space I am Python. So it's going to concatenate the name that I passed in with some other text. Then what I can do is I can assign that Python variable hello. I can set that to a Stata local macro named hello. So I'm going to pass the value of hello, that string, back into Stata, and then type end. Once I type end, I'm back in Stata mode, and I can type display hello. So when I run this, I pass the name Stata into Python. It sends the phrase hello back out of Python to Stata, and then I can type display hello, and it shows hello Stata, comma, I am Python. Okay. So that's a simple little program that would pass one thing from Stata to Python, do something with it in Python, and then pass the results back to Stata. If that makes sense. Okay. So get local gets a macro from Stata, set local sets a local macro back in Stata. Now, what about scalars? What if I wanted to do something with a number? And in Stata, scalars are stored at higher precision than local macros. Local macros, if you store a number to a local macro, I believe it's stored in single precision, which is what, 16 decimal places of accuracy? I could be wrong. Scalars are stored in double precision, which is 32 decimal places of accuracy, I believe. So if you're going to be passing numbers around, I would pass them around as scalars because they carry more decimal places of accuracy. So in Stata, I could define a scalar. I could assign the number 5 to a scalar named x, and then use the get value method or function within the scalar package to pass that scalar x into Python. And then within my Python code, x2 is going to be equal to the product of x times itself, or x squared. And then the next line, x equals scalar set value, is going to set the value of x2 to the Python variable x2. And then if we run this, we go back in, and essentially what this program does is it passes the number 5 in, squares it, and sends the result back out to Stata and displays it. So 5 times 5 would give us 25. So get value pulls a scalar into Python from Stata. Set value passes a scalar from Python back into Stata. Get value, set value. Okay. Now, what about matrices? At some point, we may want to start passing matrices back and forth. So I can define a matrix in Stata here at the top, 1, comma 2 slash 3, comma 4. So that's a little 2 by 2 matrix. And I can pass that into Python by typing matrix.get, and it will get that matrix X from Stata. And then I could compute the dot product of that matrix within Python and call it X2. Then I can pass that matrix back in, the squared matrix back into Stata by typing matrix.store X2, X2. So again, matrix get receives the matrix from Stata. Matrix store stores the matrix from Python back to Stata. Okay, just sending information back and forth. So this is what the results would look like if I actually ran that. Okay. Now, what about data? So there is a data get method built into the SFI interface. And so I could type data.get, and here I can just tell it the names of the variables and the range of observations. Whereas before, remember, I opened the data set in Stata and I got rid of some variables and I got rid of a bunch of observations. Here I can do that within the get method in Python. So I just tell get all I want are the variables mpg and weight, and then comma, the second argument is the observation range. Notice that it starts at 0. So if I want the first 5 observations in that data set, I don't type 1, comma 5. I need to type 0, comma 4, because Python the index begins at 0. Okay. So if I were to run this, it just opens the data set and it shows me these tuples here at the bottom. Okay. So that's a better way of passing data from Stata data sets into Python. Okay, so any questions about that before we look at some examples? So we're going to take what we've learned here and put them together in some practical examples. Okay, so first up, let's look at some Stata models and Python graphs. So at the top, I'm going to use this NHANES2 data set. It's on the Stata server, so I just type web use NHANES2. And then I'm going to fit this logistic regression model for high BP as the binary dependent variable high blood pressure, or high BP. The model includes age as a continuous variable, weight as a continuous variable, and the interaction of age and weight. So that fits the logistic regression model. And then I'm going to type quietly. Quietly suppresses the output to the screen. I don't want to see the results of this command. I just want to run it in the background. So I'm going to type margins, comma, at age from 20 to 80 in increments of 5. So age 20, 25, 30, 35, 40, all the way to 80. And weight equals 40 to 180 kilograms in increments of 5. So 40, 45, 50, 55, 60. And it's going to do this for all possible combinations of age and weight. And that's why I've run this quietly, because that's a lot of combinations of numbers. It's going to create a lot of output, and I don't want to see it. What I want to do is save it to a data set called predictions. So I'm going to send all of those predictions out to a data set called predictions. Then I'm going to use that data set. After I generate the predictions, I want to use the data set of predictions. And I'm going to rename 3 of the variables. _@1 contains the variable age, and that's going to be 20, 25, 30, 35, and so forth. @2 contains weight, the values of weight that I specified. And then _margin is going to be the name for the predicted probability of hypertension or high blood pressure. So if I list the first 5 observations of this predictions data set, I see age equals 20, weight equals 40, and the predicted probability of hypertension is 0.0200911. The second observation is age equals 20, weight equals 45, and the predicted probability of hypertension is 0.0274497. And this data goes on and on and on because I did lots and lots of predictions from it. Okay. So from that, if I was going to keep this in Stata, I would use a contour plot. Stata does really nice contour plots. And so here I can see the predicted probability of hypertension for values of age along the horizontal axis and weight along the vertical axis. And the color contours represent the predicted probability of hypertension. So I can see the key or the legend over here on the right. So the dark blue color means that a person's predicted probability of hypertension is between 0 and zero point 0.1, or very low probability of having hypertension. Orange, if I look at the legend on the right, means the predicted probability of hypertension is between zero point 0.9 and 1. So much higher probability of hypertension. So that's this dark orange color at the top. So what that tells me is if a patient walks into my office and says, I am 30 years old, what is my probability of having hypertension? Well, the doctor would say, well, it depends. You're 30 years old, but that's not enough information. I also need to know how much you weigh. So if we put them on the scale and we see that they weigh 80 kilograms, their predicted probability of hypertension is in this light blue area. It's pretty low. It's somewhere between zero point 0.2 and zero point 0.3. But if we put them on the scale and they weigh 160 kilograms, we would say, okay, well, you're 30 years old, but you weigh 160 kilograms. You have a pretty high probability of having hypertension. So it's a really nice way of visualizing the results of things like interactions from models. So that would be just within Stata. But a lot of people like 3D plots, surface plots. So you could take this same data set, the marginal predictions, and run this code in Python using matplotlib. So at the top, I'm going to type Python colon, and I'm going to need some of these packages. I'm going to import NumPy as NP. I'm going to import matplotlib or matplotlib. And there's some specialty things that I'm going to import here or use this TKAGG. So I'm not going to read through all of the code for you, but essentially this is a Python, a chunk of Python code that will draw a three-dimensional plot and rotate it however you want using that Stata data set. Okay. So now I have age and weight on the horizontal axes, and instead of it being a contour plot, the vertical axis or z-axis is the predicted probability of hypertension. So it's now the same information but plotted in a surface plot. So maybe you prefer that, maybe you don't, but the point is that it's very easy to run this. This is all the code I need to generate those marginal predictions in Stata. Stata is very, very good and designed to do this sort of thing, but it doesn't do 3D plots. So I can come over here to Python, import some libraries, import the data. Here I'm using that data get method from the SFI module. So I just use that to pull the data, the predictions in that I want, and then use matplotlib to actually create this surface plot.
Chuck, I have a question.
Yes, please.
Here in your sample, you consider both genders, right?
Yes.
But for example, if I am analyzing some disease that the difference in the predictions are different by gender. So you
Yes.
need to do a graph for female and male.
Yes.
So my question it is, you can do doing the plot using men and women. It's more, how can I say it, ethical to do,
Yes.
or the
Sure.
best can be the three options, male, women, and both, or
Yes.
just both, it's enough. I think I don't know if I'm clear.
Yes, yes, I understand what you're saying. This is a stupidly simple model. It doesn't capture all the information. A real model for hypertension would include things like gender, possibly race, and other things like that in here. So I agree. This is a very simple model that's not very good. You absolutely could do that. It's very easy to do. And then you could either average over males and females and just do one plot, or you could do separate plots for males and females separately, or
Yeah.
do males and females separately and one for both together.
Yeah. And you would add this as a predictors or covariates?
Yes, in the model. I will this afternoon. I'll send you. I have an example of that in another slide deck somewhere where I do that, and I'll see if I can find that and send it to you. It's very, very easy to do. It's really easy to do.
Okay, thanks.
Sure, I'll send that to you later this afternoon. And if you want to share it with other people, please send it around, email it. But that's an excellent point. I'm just using this for an example, but that model is not very good at all to just include age and weight. We should definitely include gender and race and probably other things as well. Okay, any other questions before we move on? Okay, so API and JSON data. So API stands for Application Programming Interface, or API for short. It's a programming interface that's often used for requesting data from external sources across the web, such as web servers. So it's a way of requesting data, and every API has its own syntax. So the U.S. Food and Drug Administration has their own syntax for their own API syntax for requesting data. So you'll have to go to their website and read the documentation for their API if you want to use it. Same thing for artificial intelligence, and we'll talk about that here in just a moment. If you want to use Chat GPT versus Claude versus Gemini versus Grok, they all have different API syntax. So you will have to go to their website and read about the syntax for their API to learn how to use it. But Python is very good for using APIs to request data. A lot of times, APIs return the data that you request in a format called JSON or JSON. That stands for JavaScript Object Notation. And it's a very flexible data storage or file format. It's much more flexible than flat files, things that just have rows and columns. But it's very commonly used for returning data from an API. And it uses what's called key value pairs rather than rectangular data sets with rows and columns. Stata is not very good at processing that, whereas it's child's play for Python. So that's why these, again, work very well together. So let's say that I want to go out. I wanted to create a little command called xrate, EX, for the exchange rate for money between the euro and the dollar, the US dollar, and actually, I think I wrote this before Brexit, the Great British Pound, or I guess I wrote it after Brexit. So I wanted to go out to the web from exchangeratesAPI.io. It's a website. I want to use their API to request the current exchange rate for the US dollar and the Great British Pound. Okay. So the API can be done in a web browser in the address bar. So you could just type this in the address bar, and what it will show you in the web browser then is the raw JSON data. Well, JSON or raw or whatever. So this is what the JSON data would look like here in the blue box. So API requests the data, and the data you get is in this JSON format in blue. What I'd like to do is be able to use Python to do that for me. I don't want to have to go out to the website every time I want to do this. So I'm going to create a little Stata command called exrate.ado. So anytime I want, I can just type xrate and boom, there it goes and gets my conversion. Okay. So I'm going to do this in two steps. I'm going to create a Stata command called exrate or xrate. I'm going to create that Stata command here at the top, program xrate, r class. And then I'm going to request a couple of Python things. I'm going to type Python : import main. Main is the namespace for functions. So what I'm going to be doing is creating a function for doing this, a Python function. And I want to be able to call that Python function from within my Stata command. And that function is stored in the namespace __ main __. So I'm going to, in my Stata command definition, I'm going to run those. I'm going to first import main, and then I'm going to run the exchange function that I'm going to write in Python. And then I'm going to return the scalar USD that I fetch from using the Python function exchange. So that little chunk of code, those first 6 lines of code, 1, 2, 3, 4, 5 lines of code, that defines the Stata program xrate. Below that, where it says Python : everything below that is Python code that defines a Python function named exchange. So I'm going to import some packages from SFI. I'm going to import scalar. I'm going to import requests. I'm going to import JSON. Requests uses the API features, and import JSON imports the package that processes incoming JSON data. And then I'm going to define a function called exchange. Now, if you've ever used Python and defined functions, you'll know that the spacing or the tab indentation is meaningful to Python. So it's going to take everything that's indented to be part of that function. So the URL is going to be the actual web URL that we're going to use to do that has the API request in it. And that's going to return the data in JSON format. So data is the resulting data that we requested using the API. And then rates is going to pull just the rate information from the JSON data. So JSON is going to contain other things, that data set. All I want from it is the rate, the current exchange rate. And then I'm going to pass that. I'm not going to read every line of code to you, but effectively what's going to happen is once I pull the rate for today out of that data, that JSON data, I'm going to use scalar set value to set that value back into Stata. So I'm doing two things here in one ADO file. I've written a little Stata command that calls a Python function, and then in the same file, I've defined a Python function that does the API call, receives the data, and pulls the specific data that I want from the JSON file, passes it back to Stata. So now what I can do is I can just type xrate. That's all I have to type is EXRATE, and it will immediately use the API, go out to the web, get the exchange rate, and show it on the screen. And if I wanted to use that in some other calculation, I could type return list and see that I stored that scalar temporarily in memory, and I could print that in a sentence. I could type it in a report or whatever I want to use it for. So at the bottom, I've typed display today's exchange rate for GBP to USD is, and then refer to that scalar that the command returned. So it would either display on the screen or in my report, today's exchange rate for GBP to USD is 1.1117. So the command looks like a simple little Stata command. I just type xrate. But in the background, what it's actually doing is using Python and APIs and JSON data to actually go do the heavy lifting. Okay. Does that make sense?
Thank you. Very interesting.
I'm sorry, I couldn't quite hear.
Yeah, I said thank you. Very interesting. So
Oh, good.
Seemed like quite easy to do. You use very few commands to get into the API and download the information.
Yes.
Yeah.
So here's another little example using the United States Food and Drug Administration also has a server, and you can request information from the FDA using their API. And again, the syntax is going to be different. You have to go to their website and read the instructions. But once you understand the instructions, you can use this API to request things like adverse drug events. So that's what I've done here. In the address bar in the web browser, I've typed in the API, and in the browser itself, you can see the resulting JSON data. Now this has time, it actually has dates. This is going to be a time series, and it has the count of adverse events along with some other information. So what I'd like to do is take that data that I've downloaded, pull that into Stata as Stata data, and then plot those together. So what I have here are I've done this with both Yahoo Finance. So I used the API for Yahoo Finance to grab the ETF price for the Standard & Poor's pharmaceutical ETF price. It's a kind of a measure of how well the price of that pharmaceutical ETF is doing. That's the actual price. And that's in blue. So that's the blue line, and the blue line scale is on the left-hand side in blue. And then I also pulled in the Open FDA adverse events for fentanyl adverse events. And so that's shown in red, and the scale for the red line is on the right side of the plot here. And so what we can do then is we can look at the price of the ETF along with the adverse events to compare them. And so here along about 2015, we see a little bump in adverse events. Well, when that bump in adverse events happened, the ETF price went down quite a bit. Things leveled off with the number of adverse events, and so the stock price kind of leveled off. But then in 2018, we had another spike in adverse events reported to the FDA. And again, the stock price briefly went up, but then it started coming back down again. Once that leveled off, then the ETF price kind of leveled off and started going back up. But this is a way that you can use the API and JSON information to go grab data from the web from two different locations, pull them into the same data set, merge them into the same Stata data set. And then it's really easy in Stata to create these kinds of line plots. Stata has lots of features for doing time series analysis and time series plots like this. So that would be a really handy use of APIs and JSON. It's a bit more code, and I can't squeeze it all onto one slide, but that's the principle of it is the same as what we did with X-rate. Okay. Now, here's a fun one that I did 2 years ago, and I recently updated it. And you are the first people outside of StataCorp to see this. Other people have seen ChatGPT, but I'm going to show you the new ones today. So I mentioned that a few years ago, I wrote a little command to use the OpenAI is the parent company that created ChatGPT. And OpenAI also has an API. And so you can go to their website and read the instructions of how to pass information into ChatGPT and get the responses out of ChatGPT. And so I'm not going to go, again, I'm not going to read through this line by line, but this literally is the code for the ChatGPT command that I've written. And so you store it in a file called chatgpt.ado. The top of it, where it says program ChatGPT, this is the Stata command that runs ChatGPT. And then below that is the Python code that defines the function query OpenAI. And that function query OpenAI, that is what uses the API to take whatever prompt you type in, sends it through Python, through the API to ChatGPT, gets the response from ChatGPT, excuse me, and then it brings the response back into Python and then sends the response to the screen. It prints it on the screen. It stores it as a Stata local macro, and it stores it to a file. Because some responses from ChatGPT can be very long if you're using it for code assist, for example. If you wanted it to help you write a do file to do some sort of data analysis, that might be very long, and you'd want to send it to a file, not to your screen. So that is literally the code for the ChatGPT command. So if I run it, I just type ChatGPT, type my prompt in double quotes in Stata, just like any other Stata command. And what that will do, it'll print it to the screen, but here I'm showing you the file that it creates. So it sends a poem, a haiku is a kind of short poem, that ChatGPT wrote about Stata, and it sends it to this file called ChatGPT_output.txt. Okay. So that's another way that you can use these APIs to interface with artificial intelligence engines like ChatGPT. I wrote a blog post about this. It's up back in 2023, but they've changed the API. Now, that's something else I wanted to mention is that these companies are constantly updating and improving their APIs, which changes the syntax, which means that you're going to have to periodically update your code for these. So I wrote this in 2023, and the code, the API syntax changed. So I recently wrote an update to the blog post to show people how to update it so it works again. So the code that I just showed you here is the new code, not the old code from the blog post. So this is the updated syntax for the OpenAI API. Now, I figured if I was going to do this for ChatGPT, let's just try it for a couple others. So I also did this for Claude. If you've ever used Claude, it's another AI engine. And so it's from a company called Anthropic. Again, the structure is the same. And there is a blog post that'll go up and explain the lines of code to this. So just be patient. It will appear on the Stata blog post shortly. But I thought I'd give you a preview today of this. So this is the code for Claude. At the top, there's a program that defines the Stata program Claude. Below that is the definition of the query Claude function in Python that uses the Anthropic API to send your query from your prompt from Claude through Python, through their API, gets the response, and then takes the response and sends it back to the screen to a local macro and also writes it to a file. So that's the code. And I also did one for Grok. And if you'll notice, the structure of these programs are almost identical. There are subtle changes in the AI, the API syntax. but the general code and structure of these programs is almost identical. So this is Gemini. This uses Google Gemini's API engine, and this one uses Grok, which is the X's, Elon Musk's Grok thing. So anyway, these are four different variants of Stata programs that will use Python to use these AI engines. So then now there are four Stata commands. One's called ChatGPT. So at the top, you just type ChatGPT, write a haiku about Stata. So this is the first one that ChatGPT wrote, and then I type Claude, and then I put the prompt inside double quotes. Claude, for whatever reason, kind of parrots your question back to you, your query. It says, "Here is a haiku about Stata," and then it shows you the response that it created. So Claude wrote this little haiku about Stata. Same thing with Gemini. So I would just type Gemini, type the prompt in double quotes, and it sends the response back to the screen and to a file and to a a local macro. And then same thing with Grok. You just type Grok, put the prompt in double quotes, and then it displays the results on the screen and sends it to a file and so forth. So those are four new Stata commands that you can use to access these artificial intelligence engines using Python. So even though you're typing these commands and you think they're Stata commands, and they are Stata commands, they're actually using Python in the background as the sort of computational engine, or it's doing the heavy lifting for you. So any questions about that? Okay, last but not least, I just want to mention this again. I'm not going to dig under and show you the underlying code, but it's all available on GitHub. But Michael Droste at the time was an econometrics PhD student at Harvard, and he wrote this collection of commands. They're all Stata commands. They run in Stata. You don't have to, all you have to do is make sure Python is set up to run in the background and make sure that the packages you need are set up. And once you've done that, these all just run like any other Stata command. So you can do decision trees, random forest, multi-layer perceptrons, adaptive boosted trees and regression, gradient boosting. Most of this stuff can now be done directly in Stata using H2O, using built-in official Stata commands. But Michael wrote this early on. I actually interviewed him a couple of years ago for our YouTube website, and this was just tremendous fun. He really had no purpose for it other than it looked like fun to him, and he did it. And it's up on his GitHub repository if you want to download it. There's a link right here. But again, it looks and feels like Stata, but it's using Python as the computational engine running in the background. So here's a little example where we open a Stata data set, run some random forest classification stuff, and it just sends all the results to the screen. So looks and feels just like Stata. I've written an extensive collection of blog posts about Python Stata integration because I got kind of carried away with this when we first released it. So there is a lot of information up on our Stata blog about how to use Python within Stata, and it walks step by step, assuming you've never seen or heard of Python before. How do you set it up? How do you download it, get everything installed? And then I have some other examples up there, like using support vector machines and some machine learning things like that. So these things are all up on the Stata blog if you want to read more about it in more detail. Again, I mentioned earlier, I've recorded some videos for our YouTube channel that walk you through how to do the installations of things. And that's what I have for you today. I hope I didn't run too far over time. So again, you can download all the material from today. All of those ADO files and things are at tinyurl.com/statapython. Happy to hang out and answer questions as long as you have today. But if you think of questions later on, shoot me an email at chuber@stata.com. I will apologize in advance. I am very slow to respond to email because I travel a lot. And here at the end of October, I will be gone for about 3 weeks doing guest lectures at universities along the East Coast. So the end of October through early November, I may not be responding to email much, but shoot me an email if you don't hear back from me soon. Email me again. I'm not ignoring you. It's just I'm traveling somewhere. So thanks again for being here. Thank you, Rafaela, for the invitation. This was a lot of fun and love to do it again sometime. So any questions?
Yes, thank you very much. Thank you very much. We really need it to see this combination of environments. Thank you very much. Just a quick question, just a curiosity. I
Sure.
see that Python is really going, getting stronger, and so taking places everywhere. It is good, very good to as a language. But what made you choose Python to be integrated within Stata more than other languages?
So I assume we're still recording. So I'll be as diplomatic as I can. Python is very, very flexible. Um, I'll just say it. R was designed originally to be a statistics package. A lot of people aren't aware of this, but R was designed to be a commercial stat package called S plus, and it focused on statistics. It was never really focused on things like machine learning or when it was S plus, and when it was sort of went out into the wild as R. Obviously, it's expanded a lot, but its original focus and syntax and purpose was more statistics. Whereas Python is the wild west for all kinds of things for computing. I have a book that shows how to use it for basic robotics and things like that for controlling, not robots like Star Wars robots, but like industrial machines. If you have machines that build things or whatever, you can use Python to control those things. So Python's a far more flexible, general use programming language for a wide variety of things. And so, if we were going to spend a lot of money and time and energy interfacing with something, we wanted it to be the most flexible thing around. I know a lot of people are fond of Julia. Julia is a newer language, but I don't think it's nearly as up to date as Python. So, from our point of view, Python seemed to be the most bang for the buck, so to speak. The once you could get out to me, I view it as almost like a little window outside of Stata. It's like, okay, I'm in Stata, I'm doing my things in Stata, but I'd like to go do this. It's like a little window I can see out of and go, oh, I want to do 3D graphs, or I want to do machine learning, or I want to do some sort of artificial intelligence. There are so many things out there in Python that having that interface, if we were only going to do one, that would be the one. And we might come back and do others later. I don't know. I'm not saying we will or we won't. I don't really know, but Python seemed to be the most bang for the buck. It's an American saying. You get the most, what's a different way to say it? The most flexibility and the most features for the least amount of work to get out into that world. So I think that's probably the reason why. I know that's the reason why.
Yeah, yeah. I agree. I agree. Obviously, it's very important to be able to switch between languages. So at least understanding what are the differences in case you need it, and
Right,
able to integrate with other languages and your programs and things, script and so the most important things is to be able to do what you need.
right.
You get it out and things. So yes, thank you very much. We are really
Yes.
appreciate it. I don't have any other question at the moment. Beside another one, that was something that I had in mind because I'm an Excel user. So then
Okay.
I passed to R and Python, and so a bit more focus on those programming languages. But still, within Excel, you can do many things. What
Sure.
concerned me was about approximations of numbers when you switch between languages, such as you're using Stata and you have such, such a sort of approximation within numbers, and then you pass to Python. Do you lose some information somehow, or you still be able to maintain the precision?
Okay, that is a very, very good question. Thank you for asking that. And I should have emphasized this more. When I mentioned local macros is just sort of in Stata, local macros are a handy way of passing numbers and strings around if it's not really important. But if you really want to do serious computations in Stata, you would pass things around as scalars. So programmers at Stata who are writing official commands would pass any number would be passed as scalars. Which is why if you're going to pass something into Python, you would want to use the SFI interface to pass a scalar very carefully as a scalar through the SFI interface into Python to retain as much precision as you can, because I believe scalars are stored, I can't remember if it's 32-bit or 32 decimals of precision, but scalars are stored at as much precision as you can have, and that gets passed into Python at the same precision, I think. I'm pretty sure Python has the same level of precision for storing scalars. I could be wrong about that. Same thing for matrices. So that's why it's preferable to use the SFI interface to pass a matrix from Stata into Python to retain all of that accuracy. Excuse me. Whereas just passing, if you just type matrix and you send it in kind of the informal way, I don't know that it retains all of the precision. So that's why that SFI interface is so important because of that. You're guaranteed to keep the as much precision as you have originally. That's a very good question, and I should have emphasized that more earlier.
Thank you very much.
Sure.
I don't have any other question by my side. I don't know if anyone would like to jump in and ask a question to Dr. Huber directly.
Okay. I would like to thank you, Dr. Chuk. It was a
Yes.
great experience. Your class is the best. You have you
Oh, well,
have
thanks.
a lot of knowledge, and you speak very slowly and easily, and we can understand even difficult things. So thank you very much for this
Oh, well,
presentation.
thank you for having me. And I'm happy to come back anytime. I have loads of these talks. So,
It's great. It's great. It's always good
sure.
to learn with people that have a lot of experience. So it's so good. We learn a lot.
Well, thank you.
Mm.
Thank you.
Okay, that's it.
Okay. Well, thanks again, and hope to see you again soon.